All right, so section 5.5 is about solving rational equations and inequalities. So first we're going to focus on the solving equations today, and then we'll talk about inequalities last and do some problem solving. So an extraneous solution, it's a solution derived from the original equation that is not an actual solution. So I said give a few examples of problems that have extraneous solutions, and then what do they have in common. So if you have a fraction with a variable in the denominator, right here, so a fraction, if you have a variable in the denominator, because we know that the denominator cannot equal 0. Okay, so if there is a fraction, that's what we have to watch out for. Okay, that's when it would be undefined. Okay, and then really we've been talking about square roots, but any even root this would work for. Okay, and if you have a square root, you can't take the square root of a negative number. Okay, so cannot take an even root of a negative number. That's when you'd have no real solutions, because your solutions would be imaginary. Okay, and then the last thing you have to watch out for, so again, think of the domain. We talked about fractions, square roots. Do you guys remember the last one? Yeah, the logs. Okay, so if you have a logarithm, can't take the log of 0 or negative numbers. And again, those are undefined values. All right, so like I said, first we're going to be dealing with equations. These are Algebra 1 type of equations, but they have some fun twists in there where you're going to have to think a little bit. Review, some of it's review from 5.2, 5.3, so you might have to think about how are we going to solve these types of equations. I'm going to show you some new strategies as well. All right, so for the first one, you have x minus 18 over x. I think probably, well, what are you guys thinking? What would you do first? Are some of you thinking of like moving this over? If you have a fraction, you don't want any variables in the denominator, so how do you move that out?
Add the 18 over x to the 3.
That?
Like that side and then multiply by the x.
Okay, so eventually you'd get a common denominator, right? Yep, and you could either get a common denominator over here or over here. And if you did that, we could get a common denominator here, right? This is like over 1. We can think of that as over 1. So to get the LCD, we can multiply the top and the bottom. Christian, what's our LCD going to be? Yep. Okay, so if I want this denominator to be x, then I'm just going to multiply the first one by x over x, right? So x times x is x squared minus 18 divided by x over 3. Once you get one term equal to another, even if it's a fraction, the only way to move this out of the denominator is to multiply by the denominator. Okay, so the first thing we did is we got the LCD. Now we're going to multiply by the denominator. So if I multiply both sides by x, those will cancel. So I have x squared minus 18 equals 3x. One thing you do not want to do here is divide by x. First, if you did that, you would have to have the 18 over x and you'd just be at step 1 again. Okay? Notice here I have an x squared, I have 3x, and I have negative 18. What should I do? Okay, yep, so I want to put everything on one side so that you can factor it, because this is a quadratic trinomial. X squared minus 3x minus 18 equals 0. Okay, so get all terms on one side. And factor. Good job. Okay, so now I have x squared minus 3x minus 18 equals 0. This one, hopefully the factoring will go really quick because 18, we think 6 and 3. So I have a negative 6, positive 3. And then we're going to set both of those equal to 0. So x minus 6 equals 0, or x plus 3 equals 0, which leaves us with x equals 6 or x equals negative 3. Do you guys know why we do the or with these two whenever we have the zero product property?
It can't be both at the same time.
Right, it won't be both of them at the same time. It's either one of these that make this true. Okay, so we know that it's one of those that is our solution. So now we have to make sure we check for extraneous solutions. And when you're checking, again, think of the domain. Tori, for this one, what could x not be if you're looking at the original? X can't be 0. How'd you know that? Yep, x is the only thing in the denominator here, so if we set that equal to 0, so both of these should work when I plug them back in. So the first one I'm going to check is x equals 6. We're going to practice writing out the check. So when you write out the check, you're just solving this one side of the equation. 18 divided by 6 is 3. 6 minus 3 is 3. Yep, those are going to be equal. And then we're going to do the same thing with x equals negative 3. Okay, so we're going to also check that one. So I have negative 3 minus 18 divided by negative 3. We're going to see if that equals 3. When you have this minus, you can think of it as minus negative 6. So negative 3 minus negative 6 we know is really going to be plus 6. So 3 does equal 3. Yep. So then this is our solution if they both check. All right, now I told you I was going to show you a new strategy. That's what we're going to do for B. So the first thing you want to do is find your LCD, and if you already started and you multiplied the top and the bottom of this by 4 and the top of the bottom of this by x, you can do that. Notice that you have fractions all the way across here. So your LCD would be 4x. What you can do is multiply each side by the LCD, and that's going to get rid of all of your fractions. Now, when you multiply each side by that, this is 6 over x plus 5 over 4 times 4x, negative 7 over 4 times 4x. when you multiply, because this is plus, you are going to multiply 4x times 6 over x, and you're going to multiply 4x times 5 over 4. So you do have to distribute. When you multiply here, the 4 and the 4 are going to cancel, and you'll have negative 7x. Okay, when you multiply here, this is x divided by x, so those are going to cancel. You'll be left with 4 times 6, which is 24. Okay, and then here, the 4's will cancel, and you'll be left with 5x equals negative 7x. And then from here, you just have a two-step algebra equations. So you're going to get all of your x's on one side to get negative 12x equals 24. Divide both sides by negative 12. So x is going to be negative 2, and then we're going to check to make sure that that's our solution. Now again, that's not the only way that you could solve it. Okay, you could do what we did in the first one, where you're getting the like terms, and then you can cross multiply. That would be another strategy. Okay, so then when you plug this in, you have 6 over negative 2 plus 5/4 equals negative 7 over 4. 6 over negative 2 is negative 3. If you want, you can also just get your LCD then. So if I want the denominator to be 4, right, this would be negative 12 over 4. That would be negative 3. Negative 12 plus 5 is negative 7. So negative 7/4 would equal negative 7/4. Okay, and the reason why this strategy is nice is once we multiply by the LCD, we had no more fractions. Okay, so if you get the LCD of all of the denominators, then you can distribute and then simplify, and bye-bye fractions. Okay, for C, you have 5x over x minus 2 equals 3x plus 4 over x minus 2. Now, notice that both of the denominators are the same. If the denominators are the same, guess what else has to be the same? The top, the numerator. Okay, so if the denominators are equal, the numerators must be 2. Okay, so if you notice that both of these are x minus 2, or even if you multiply to get those, then you can just set the numerators equal. Okay, so for this one, we would just set up the equation 5x equals 3x plus 4. Now, you could also cross multiply, foil them out, distribute, get everything on one side, and that would be another way to solve it. More work, but you get the same result. And then we have to check it. Okay, so we got x is equal to 2. Yeah, Brian, tell me what you think is going to happen. Brian, what's going to happen?
Oh, so the denominator is x minus 2.
Mm-hmm.
So if x equals 2, then you have 0 in the denominator. That doesn't work.
Yes, okay, so even though, like, you can see here, 5 times 2 is going to be 10, okay, you are not just going to say, oh yeah, these are both 10 over 0. They work out, okay, because they are the same, but the reason why this doesn't check is because you can't have 0 in the denominator. Okay, so if that happens, then this is an extraneous solution. And what you would say for this is that there is no solution. So that is what you would write on your answer line, okay, is that there's no solution. Okay, you would still need to find the extraneous solution and check it. Okay, but 2 would not satisfy that equation. All right. So for D, we have 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. Okay, now notice for this one you do have 3 different fractions, so this would be a good one to multiply each side by the LCD. Will you guys write down what your LCD is going to be for this? Yep. Okay, so remember what I told you I do whenever I'm finding LCDs? I start with the first one. The denominator is x minus 8, so I have to have that in there. This one is 2, so it's 2 times x minus 8, or 2x minus 16. It's easier to think of them as your factors, though. Okay, now, instead of multiplying the top and the bottom of this by 2, and the top and the bottom of this by x minus 8, and the top and the bottom of this by 2, I multiply each side by the LCD so that they cancel out. Okay, so the key here is to remember that you are going to be multiplying both of these by the 2 times x minus 8. Because you only have one fraction here, those do cancel out. I'm just going to give myself some room over here. So you're left with 2 times 11. I'm going to write it like that for now. And here we'd have 2 times x minus 8 times 2x minus 5 over x minus 8 plus 2 times x minus 8 times x over 2. Okay, so I'm writing that out so you guys can see that I'm multiplying both of these by that entire LCD. Okay, so then I can cancel the x minus 8s, and I'm going to do 2 times 2x minus 5. Here, the 2's will cancel, and I'm multiplying x times x minus 8 equals 22. Okay, so then I have 4x minus 10 when I distribute, plus x squared minus 8x. So once you see there's a combination where you have x's and x squared, that should be your hint that you're going to end up doing what? Factoring. Okay, so you have x squared, negative 8x plus 4 is negative 4x minus 10. Bless you. Okay, so then I'm going to move the 22 over so I can factor. So x squared minus 4x minus 32. Okay, so I know to get to 32 I could do 8 times 4. If I make the 8 negative and the 4 positive, it'll add to negative 4x. So then the two solutions I will get are x equals 8 or x equals negative 4. And then I'm going to check both of those. Okay, so the first one I'll check is x equals 8. And when I do that, right away, what do you see happens? What happens when you plug in your 8? You're going to get no solution, so I'm just going to put the 0 here. 16 minus 5 is going to be 11. Okay, so you just have to show that it is undefined because you have 0 in the denominator. So that means x cannot equal 8. Okay, so that's an extraneous solution. Let's also check x equals 4. Negative 4. Okay, so I have 2 times negative 4 minus 5. Make sure you guys are doing your checks as well. Okay, so the first step, you're just plugging everything in, so you're showing that. This part you can do in your head. 2 times negative 4 is negative 8. Negative 8 minus 5 is negative 13. Negative 4 minus 8 is negative 12. Okay, and then once you see that this is negative 12, I would just get your common denominator. So if the denominator is 2 here, what would you multiply by on the top and the bottom?
Negative 6.
That, yep. Let's simplify this first though. So 13 over 12. So I would just multiply by 6 times 6 times 6, because a negative over a negative will be a positive. So that will be negative 24. And then I have 11 over negative 12. Just going to put the negative on top. Okay, and 13 plus negative 24 is 24 minus 13 going to be 11? Yep. So negative 11 over 12 equals negative 11 over 12. Yep. So then your only solution is going to be x equals negative 4. Okay, so you wouldn't even write the other one on the line. All right, now I know that this has some blanks in it, but I want you to read over it. I am going to give you the numbers, but I don't want you to just fill in the numbers and not read it. So I'm going to give you a few seconds to read through that, and then I'll give you the numbers.